Assalamualaikum warahmatullahi wabarakatuh, and good morning to all the listeners. Alright, so for this video presentation today, I want to talk about latent heat. Alright, so what is latent heat basically? Latent heat can be defined as the energy transfer of a system that does not affect the change in temperature but affect in the phase change. For example, when we want to freeze a glass of water, right? So when the water undergoes freezing process, the water turns from liquid state into a solid state. And when this process is happening, the amount of heat that is absorbed by the water will not affect the temperature change, because the heat will be used completely to change the physical state from liquid to solid. Alright, and mathematically, the latent heat can be explained in this formula. What does L means? L means is the latent heat. What does Q means? Q is the amount of heat transfer, and M is the mass of the substance, which is in kilograms. So latent heat can be categorized into two types: latent heat of fusion and latent heat of vaporization. So latent heat of fusion means the heat required when the phase changes from solid to liquid or from liquid to solid. Meanwhile, the latent heat of vaporization is the heat required to change from liquid to gas or from gas to liquid. Alright, and the equation to explain this latent heat can also be explained like this, which is we just rearrange the first equation where L is the latent heat of fusion or latent heat of vaporization, Q is the amount of heat, and M is the mass of a substance measured in kilograms. And when Q is positive, means the energy or the heat transfer is absorbed, which is from liquid to solid or from gas to liquid. And when Q is negative, which means the heat transfer is being released, which is from solid to liquid or from liquid to gas. Right, so that's all from me. Thank you for listening.
So let's dive into the discussion of latent heat more. Let's say I have a cup of insulated water that contains 600 grams of water initially at 18 degrees Celsius. Later on, I add in another 250 grams of ice into this cup. So this is where latent heat shines, because you see, if we were to answer this question, that is, what is the final temperature of the system? We cannot find that at first, but you see, because of the latent heat, we must find the latent heat first to fully melt the ice before it can gain any temperature. By that, we plug in this equation, that is Q equals to Lm, where L is the latent heat of fusion of water, that is when ice is turned into water times the mass of the water. We get that 83,500 joules needed to fully melt the ice. So we have to find out that what about the water? Does the water have enough heat to supply to the ice to fully melt it? We plug in this equation, Q equals to MC delta theta, where the final temperature we use 0 degrees Celsius because it is the lowest that the system can get. So after we calculate this equation, we get that we need the water can release about 45,208.8 joules to release to the ice. You see, these two numbers, they don't equal. That means that the ice needed more energy, needed more heat for it to melt completely. So the water doesn't supply enough of it, and there are still ice that are not melt. The ice haven't melted completely, but the water has already reached 0 degrees Celsius. So that is the final temperature of the system, 0 degrees Celsius. Let's get into the second question.
Okay, so we move on to the next question. So the B question asks how much ice remains when the system reaches equilibrium. So first step, we have to know what is the meaning of system at equilibrium. It can determine as the net heat transfer of the system is 0, or there is no heat transfer between ice and water, or we can call it as thermal equilibrium. So that's the meaning part. So we move on to the calculation part. So from the heat ice and heat water that we got from the first question, we when we add the both value, we can get the heat needed to melt the ice completely. So the
2, 3.
so the answer from Q ice plus Q water, we get 38,312.8 joule, which means the ice still need this amount of heat to be absorbed to melt the ice completely. So then we substitute this value to the equation Q equal to M times L, which M is refers to mass of the ice remains and L is refers to the latent heat fusion of the ice. So M equal to Q over L, which Q is this value, and latent heat fusion of the ice is 334,000 J over kg, and finally we get 0.1147 kilogram, or in gram 114.7 gram. That's all. Thank you.
Okay, so based on this topic, latent heat, what can we really eat in our daily life? There are various things occur via latent heat process around us that include the melting of ice, the boiling of water, the formation of rain, and even when we are sweating. Let's take an example, which is the melting of ice. This process is called latent heat of fusion. As we all know, the latent heat of fusion is the amount of heat required to change a system from solid to liquid at constant temperature. So initially at 0 degrees Celsius, an ice cube melt by absorbing the latent heat energy. It will change its form into liquid and become water. Then after that, the boiling of water. This is due to the latent heat of vaporization, which is the amount of heat required to change a system from liquid to gases. For example, when a pot of water is kept boiling, the temperature remains constant at 100 degrees Celsius, as the latent heat absorbed used to break the chain between molecules from close to one another to the freely moving molecules. Thus, the water become gas.
Okay, so that's all for our video presentation today. Hopefully you enjoy and get useful information from it. That's all from me. Bye.